Hello, everyone. It's Dan Sandig from the Institute for Catastrophic Loss Reduction. Thanks very much for joining us again today. Today we have our first seasonal forecast webinar for 2018. So we're happy to have Richard Carr from the Canadian Forest Service with us today. We'll have another forecast webinar on the hurricane season provided by Bob Robichaud from the Canadian Hurricane Center on May 31st, so roughly 2 weeks from today. Hopefully you've received the invite for that event. Before we get started, I just want to remind people how to ask questions. So we'll have, as we typically do in our webinars, we'll have a presentation followed by some time for questions and answers with Richard. So if you could use the question and answer and Q&A function at the bottom of your screen, if you scroll over the screen, or possibly top, if depending on your computer. And feel free to ask questions anytime throughout the webinar, but we'll be holding all questions until the end, and we'll have a discussion. So today we have Richard Carr, as I mentioned, from the Canadian Forest Service. He is a fire research analyst at CFS. Richard is involved in fire weather briefings for several national groups like Canadian Forest Service, CIFFC, National Emergency Management Personnel, and he's also involved in the North American Seasonal Fire Assessment Outlook. So he's certainly well positioned to give us a good presentation on the outlook for Canada. So with that, I'll pass it to Richard.
All right, thank you, Dan. Well, I'm Richard Carr. I'm working at the Canadian Forest Service, Natural Resources Canada in Edmonton, Alberta. I've been here for a little over 20 years now, doing various things, mainly weather-related work related to wildland fire. So my title is Fire Research Analyst. I'd like to qualify that with the word wildland, since I don't have anything to do with structural fires really, but except for, where we get to interface events, I guess, between forest and human development. So I can see by my picture, I don't usually put my picture on a presentation, but I thought I'd throw it up there. If anybody has seen any of my former colleagues, Carrie Anderson's presentations, you can see I look a little different than Carrie, and my presentation will look a little different as well. So with that, we'll carry on into it. Just a little bit of an agenda here. So the presentation provides some background information, first few slides. We'll take a look at the 2017 fire season, take a look at current global climate influences and Canadian conditions. I'll describe the forecast methodology that should be fairly familiar to people that have seen Carrie's presentations in the past. And then at the end, we'll do a few slides relating to the 2018 forecast. And we do this monthly, so that'll be the May 1st run that we will look at today. First, we'll get into some background information slides. A few general points. The forecast information is available in two places, and they look a little different on each of these, just depending on the final purpose of it. I'll explain that a little bit more later in the presentation. The first one is the Canadian Wildland Fire Information System, or CWFIS. If anybody's unfamiliar with that site, you can just Google the CWFIS acronym and should get plenty of hits for that, since it's a fairly well-known system. The URL for both of these is on the slide. So CWFIS and the North American Seasonal Forecast Assessment Outlook. That's hosted in the US at the National Interagency Forest Fire Center there in Boise, Idaho. So that's a collaboration between Canada, USA, and Mexico. So our forecasts at the present time are based on Environment and Climate Change Canada, or ECCC, seasonal forecasts. Some information contained in the CWFIS. We use some visual assessments of other models' output to help with the North American outlook. And from time to time, we get some advice provided by provincial agencies, possibly some feedback. Some of the provinces have their own methods of doing a seasonal forecast. So the provinces are involved to a certain extent. We're hoping we can involve them more, and that should evolve in the future. Wildland fire in Canada, fire numbers and area burned are quite variable, as you can see from the graph here. The orange line is the number of fires from 1970 onwards, and the blue histogram is the area burned in hectares. Quite variable. The early part of the record in the 1970s, maybe not quite as accurate as recent years, just because the methods of measuring the burned area and maybe even the number of fires wasn't quite as good as what it is today. Still though, 1989 stands as the year with most area burned. There's a couple of years in the mid-1990s with large areas over 6 million hectares as well. And over the years, we can see a bit of a decrease in the number of fires, but recently I think we've had an increase in area burned. In the past 5 years or so, we've seen fairly consistent high numbers, with the exception of maybe 2016, but of course we had a lot of spring activity with the Horse River fire at Fort McMurray. The rest of the summer though was quiet, but 2017, which I've just placed to the right of this graph, shows resurgence of area burned, over 3.5 million hectares or so, and the number of fires fairly comparable with the starts we've seen in the past few years. So I did get asked a question a few days ago about why we see the number of fires possibly decreasing, yet the area burned increasing, and it's probably a whole variety of reasons for that. First of all, people may be more aware of fire danger and maybe more careful with fire. We might have changing atmospheric conditions that produce more stability and less widespread lightning. The area burned may be a result of changes in the forest itself. If areas are left unburned for a length of time, then we might have denser growth and maybe more intense fires that can carry on longer. And I think with warmer conditions, we just get more days with high to extreme fire indices. I'll take a brief look at the Canadian Wildland Fire Information System. This is the front page. So the 3 panels in the middle are the fire weather, fire behavior, and hotspots. So if you click into those, you can look at a whole bunch of different themes under each one. I won't go into too much detail there. You can explore it as you wish, or you might have seen that already. We also have an interactive map, which I've circled there and just brought up a screenshot of a particular day. So you can overlay active fires, hotspots, and a few other themes on that. You can zoom in, you can pan. We've just recently updated that with Open Layers 4, so it's a little neater than it was, bigger image. The legends, the overlay list isn't quite as intrusive. And you can also maintain the same scale between days. In the past, if you change the date, you'd have to go back to the full zoom out and then re-zoom into your area, but now you can zoom back and forth without having to change the scale. And the monthly and seasonal forecast, of course, is listed on that page as well, so that shows the location of that on the CWFIS page. Now, if you take a closer look at the Fire Weather Index, or the FWI system, the end result, the FWI at the bottom there, which is reclassified into a descriptive class that you see on the fire danger signs to the left, well, that's a combination of half a dozen other calculations. I've got the DC, or the drought code, highlighted in red font, just because it's useful for a seasonal forecast. And at the bottom, I've got another box in green. So to reclassify the FWI into something that we can use statistically, it's an exponential function, so we have to linearize that. So we do that with the severity rating. We calculate a daily value, but we can sum those into monthly or seasonal values as well, and of course do different analyses on those, like get the mean and min-max, and it's all a nice linear function. If we take a closer look at the drought code, that represents the moisture in the deepest layer of organic soil, as you can see in the diagram, the humic layer. The depth of that layer varies quite a bit across the country. In very dry areas, such as interior valleys in British Columbia, where there's not much forest, it might be almost absent. To get deep layers in the forest floor with a good peat layer, fairly moist areas, well, might start at 5 or 7 centimeters down and go down to 18, 20, maybe 25 centimeters or more. It takes about 3 millimeters of precipitation to start wetting that area. So, of course, that minimum amount will just touch a little bit. So, if we want to get good moisture in there, we need probably 20 or 30 millimeters of rain or more. That's fairly important for fires carrying over. They can smolder in that layer for many weeks and even over the winter sometimes. So it's got a really high value of the drought code, very dry layer. It might indicate smoldering and, of course, possibly more volatile conditions in the spring. So things that affect spring DC, spring values of the drought code. Well, one of the biggest influences is the ENSO, the El Nino Southern Oscillation. On the diagram on the left-hand side, we've got a La Nina, the negative variation of that. It tends to produce fairly dry conditions in the winter and spring in northern Mexico and the southern United States. We tend to get more of a surge of Arctic air coming down, covering most of Canada, and I think we've seen a fairly typical pattern of that over the past winter and spring with a fair amount of cold weather, a lot of snow in some areas, and certainly a kind of a prolonged winter. Suddenly jumped from winter to summer during April with very cold temperatures at the beginning of the month and very summer-like temperatures in some areas at the end of the month. And the opposite of that, the El Nino tends to strengthen the southern branch of the polar jet stream, as you can see with the red arrow on the right diagram, tends to bring more rain to California and the southern US, but maintains drier winter conditions over western Canada, even into the spring. The effects will usually carry on into the spring there. There's other oscillations. PNA is Pacific North America, PDO is Pacific Decadal Oscillation, AO is Arctic Oscillation, MJO is Madden-Julian Oscillation, which is a fairly fast-moving change in the tropical convection, which will circle the globe in 30 to 60 days and may help to bring more moisture across the Pacific Ocean, may help to modulate the subtropical high-pressure areas that alter the position of the jet stream. Those all affect things at different time scales, different intensities, and the effects are probably not quite as well understood or described as we have with the ENSO. So we're just taking a closer look at the ENSO and the El Nino Southern Oscillation. As in the diagram here, the positive phase of the El Nino, we've got warm ocean temperatures off the west coast of South America. And the atmospheric pressure is higher over Darwin, Australia. That's the blue dot on the left-hand side. It's just kind of off the map a little bit. And Tahiti, the blue dot towards the center of the globe there. And the opposite phase, the La Nina, that warm water is replaced with cold water, and the atmospheric pressure trend reverses as well. So we get higher pressure over Tahiti than Darwin. So besides affecting climate in Canada, it can cause all sorts of global weather extremes, floods and droughts all over the Earth, really. Events persist somewhere between 9 and 12 months, usually. They might be a bit shorter. Sometimes we can get events lasting 2 years or more. And I think that's more true with the negative phase, the La Nina. Periodicity is very irregular. Events recur from 2 to 7 years apart. And I think it's probably a little hard to predict. We tend to get the indexes strengthening through the late spring and early summer, reaching their maximum strength in late fall or winter, and quite often fading again the next spring. So I've just got a kind of a partially complete diagram here of some of the fire problems in Canada associated with ENSO springs. And we've got both positive, the El Nino in red, or the La Nina in blue. I've thrown in a few summer things just in orange, although they're not really related to the ENSO effects as the diagrams have shown previously. So if you take a look at the top, the most area burned in 1989, we had a fading La Nina. Second most area burned, we had the opposite effect in 1995, we had a fading El Nino. I've used fires in Alberta just because, for one thing, I'm based here and I'm fairly familiar with some of the large events. But we might have a I guess, a greater influence from these ENSO events in Alberta too, both with the Rocky Mountains and the proximity to the Pacific Ocean. So Virginia Hills in Alberta burned several 100,000 hectares northwest of Edmonton in the spring of 1998, and the yellow box highlights the month. So a lot of these occur in May. Chisholm, Alberta, 2001, with a fading La Nina. In the summer of 2003, of course, we had a big fire event through southern British Columbia and parts of southwestern Alberta. So that was more of a summer event, and it may or may not have been related to a variation of the fading El Nino in that particular year. Slave Lake, Alberta, 2011, of course, fairly strong La Nina. Then from 2013 through 2015, we had a lot of summer area burns and fairly neutral conditions as far as the ENSO index goes until 2015, when we had kind of a prolonged and strong El Nino. Of course, 2016, the El Nino tends to fade, but still fairly strong throughout the spring, and had a lot of hot, dry weather through Western Canada during that spring, and then, of course, the Horse River fire at Fort McMurray. In 2017, well, it was a kind of funny year. We had kind of a weak negative index at the beginning, but it was fairly neutral throughout the year, and then went more negative towards the end of the year. Once again, a fairly active summer fire season there. 2018, right at the very bottom, you can see that we're starting again with a bit of a La Nina at the beginning of the year. I think if the next couple of months were plotted on there, we'd probably see more of a trend to neutral conditions. All right, so the forecast of ENSO are represented in climate ensemble. So the ensemble is a model that consists of several different elements, all with slight variations in either the initial conditions or the physics that's represented in the model. So we got this whole group of models trying to predict the same thing, and therefore you get a whole bunch of different outcomes for the same prediction. So what's used by ECCC, or the Canada Centre for Climate Modelling and Analysis Models, and that centre is actually in Victoria, British Columbia. So what we use out of those are temperature and precipitation forecasts, and they can be deterministic, trying to give actual predictions of amounts or a probability of events happening. So each of those ensembles consist of 10 members, and they each run for 12-month forecast. We don't use the full 12 months in our seasonal forecast. We'll go through the end of the summer, but that's about it. And you might see the acronyms there, CAN-CM3, CAN-CM4. The CM4 is a more recent model. Probably won't talk too much about the models themselves, since I don't know the internal workings of those. And you might see CAN-CFS as well, a Canadian Seasonal to Interannual Prediction System. So that's what we get from the amalgamation of all these models together. Here's just an example of what we get from an ensemble forecast, and just looking at Edmonton International Airport here, the CIG, the airport code. So we've got temperature and precipitation. The top two are from the CM3, the bottom two are from the CM4. You see with all the purple lines in there that there's a variety of outputs from all the different ensemble elements. So the amount of spread in those ensemble elements gives an idea of the confidence in our forecast. If there's a large spread, as you can see from inside those circles, maybe there's a bit more uncertainty during that period. All right, so that's kind of the basics of the introduction there. We'll go into the 2017 fire season. National statistics. Most of these are from the Canadian Interagency Forest Fire Centre situation reports, and CFS does a kind of a related situation report. So the numbers come from those, except for the one with the star, like the total area burned at the end, is from the National Fire Database. All right, so in 2017, we really started out quietly. At the end of May, the number of fires was about half the normal for the time of year. The area burned was ridiculously small, about 4% of normal, with 8,000 hectares burned at the end of May. In British Columbia, the rain really stopped about that third week of May, and it's probably But the last time they got a decent amount, 5 millimeters or more in a lot of regions. At the end of June, the number of fires was still sitting about 50%. The area burned had increased a little bit, and that was mainly in Yukon Territory, actually. We just didn't get many triggers in June in British Columbia, even though towards the end of the month, the forests were probably quite receptive to lightning strikes and human starts. At the end of July, we've got August 2nd as a date here. The number of fires had jumped to about 70%. The area burned had jumped over 1 million hectares, so it was sitting about getting close to 60% anyways. Then by the end of August, we're up to 84% of the number of fires, and the area burned had jumped over the normal for the time of year. And at the end, I kind of put a question mark there just because I don't really have final numbers there. Somewhere over around 5,500 fires, we'll say maybe. Area burned, probably 2.5 million hectares or a bit more. So I finished the season with about 140% of the average area burned. You see the trends in the bottom graph there, the fire occurrence. At the bottom, once again, the number of fire starts remained below the average, 10-year average, all throughout the year. But as you can see, with the area burned, those histograms pass that red line as we get towards the end of the fire season. It's probably a bit of an unusual fire season in that we got fairly sustained fire activity in parts of the west through September and even into October. Let's look at the season by provinces here, or agencies. At the Yukon, Northwest Territories, Manitoba, and Parks Canada all reporting slightly more fires than normal. The rest of the provinces had less than normal. The big story, though, was the area burned, with BC setting records for both the largest single fire event, which is actually an amalgamation of about a half dozen fires into one, and over 1 million hectares burned, so most that they've had in one single season. Yukon had a fair amount of area burned too, with over 300,000 hectares. Northwest Territories had 2 active areas, one on towards the north end of the Mackenzie Valley up around Fort Good Hope, and the other in the South Slave region a little later in the summer, just southeast of Great Slave Lake and north of the Alberta or Saskatchewan borders there. I'll just go through the hotspots here by month, or approximately by the month. If you look at the Canadian Wildland Fire Information System, either on the hotspots map or the interactive map, you can see displays like this. We've got this funny blue shape in the prairies, which is an area where it's really hard to determine if you're seeing a wildfire or maybe an agricultural burn of some sort, or maybe even a plowed field that tends to soak up sunshine and reflect a thermal signature. So we've got that shape kind of outlined roughly there, that where it's really doubtful if we're actually looking at wildland fires. The rest of the hotspots, though, for the most part, should be fire. So starting at June 30th of last year, you can see a number of hotspots in central Yukon and a few more in northeastern BC, northwestern Alberta, and just a few scattered points elsewhere. By the middle of July, we've seen the increase in fire in BC. We've got a lot of those fire starts around the 7th or 8th of July from lightning strikes in central BC. And fires in Yukon had continued to grow. And we're starting to get a patch in just west of James Bay in northern Ontario, which itself was a bit unusual too, since it's an area that doesn't really have a history of too many large fires. Very low-lying elevation there, probably a lot of water in that area. There's a few communities scattered about, not a huge population. But I think with continued drying, we've probably got some of that kind of standing water or boggy area dried out enough that we've got some pretty good fires going in that area. July 31st, BC fires continued to grow. We're starting to see a bit of activity in the South Slave area, and those fires in the James Bay area of Ontario continued to grow. Middle of August, South Slave area in BC were quite active. And then towards the end of August, things started to slow down in central BC, but we got an increase of activity in the southwest part of the southeast part of the province, and then down into the Pacific Northwest USA. Of course, that continued through September, and it's quite active on the U.S. side. We got the fire bursting through the Rocky Mountains into Waterton Park. We got some grass fires in the prairies, and that continued through October. And for anybody that's in California, well, I can probably say that, yeah, the late summer, the early fall was probably the worst for them down there. As far as predictions in 2017 go, it's probably a tough year for the climate models to forecast, I think. Over the past couple of years, I don't know if you studied the previous chart too closely with all the ENSO events and spring fires. Well, over the past couple of years, we've had a fairly rapid flip-flop of index from positive to negative, or negative to neutral and back to negative. So I don't think the events have been lasting quite as long as they have in the past. So maybe tough to forecast. The plumes that we see in these charts at the top are all the different climate models trying to predict the strength of the ENSO events. What we need is a 3 or 4 consecutive month period with values exceeding those red horizontal lines. That's plus and minus 0.5 degree sea surface temperature out in the mid-Pacific. And look at the March plume. We had a lot of the models predicting a return to El Nino conditions during the year. By the time we got to June, that same plume had really flattened out, and most of the predictions were probably leaning towards more of a neutral index, and that's in fact what happened. So we looked at an early season forecast, might have been quite a ways off just because of this uncertainty in prediction. Now, things that may have influenced the summer fire season last year were what we have as a kind of a weak Madoki ENSO or El Nino, and that's a Japanese term meaning a bit different yet very similar, or something to that effect. Anyways, in this case, within that red oval on the sea surface temperature anomaly chart, we tend to have warmer water in the central Pacific and cooler water towards South America, and to the west of that towards New Guinea, Indonesia, Philippines area. Also, we had a weak continuation of the positive Pacific decadal oscillation with warmer water close to the British Columbia and Alaska coasts, and kind of a weak Madden-Julian oscillation throughout the year too, which may have prevented too much tropical moisture from getting moved across the Pacific Ocean. So with our own seasonal predictions, top is our May run, the bottom is the July run. Top left is our June prediction from the May run. So we have a lot of area that's highlighted in red there. I guess the only area that really got active was Yukon in the yellow circle. By July, we'd had to trim down, I guess, area in Western Canada, which maybe wasn't that great. I mean, the area in Yukon we still had represented in July, which is fine. The area in BC may be a little too far to the northeast. The area in northern Ontario near James Bay was probably all right as well. But from the May run, when we're looking out as far as August, we probably didn't do a good job with the bulk of the fire activity in that yellow oval, but really not much area represented on the forecast map. By the time we got to July, probably got a better prediction, I think. Maybe not so great in central BC, but for August, I think the area was captured well. And at the time, we started to produce a map with a new look there, and probably did a better job of capturing the actual area that would have had increased fire potential. And we're still playing with that classification of the outputs, and I'll describe another new look that appears a little later in the presentation. As far as the North American seasonal assessment goes, 2-month lead time, so looking at May's forecast for July on the left. Probably not too great. Maybe the area around Great Slave Lake was fine, but a little too far to the west, possibly. June's forecast for August, we didn't really represent anything there, and neither did the US. And July's forecast for September maybe did a better job predicting some of the areas in southern BC, maybe touching on the grasslands and the prairies, and down into California and Nevada. But still, I think we performed pretty poorly for 2-month lead time on forecast last year. Do note that the countries use different methodologies. Canada here, we're using more of a deterministic type method. We're actually using model output and predicting the anomaly of the fire weather index, or the seasonal or the daily severity anomaly. The US uses more of a kind of a regional expert assessment, based on climate conditions, weather conditions, and state of vegetation. So they have regular calls, and they get all the information together, and they adjust their areas a little bit based on that type of assessment. So I kind of touched on some of the possible problems with the 2017 predictions. As I mentioned before, the rapid flipping of the ENSO index, as you can see in the gray shaded area on the chart there. Gone from a fairly strong El Nino in 2016 to moderate La Nina, back into a neutral condition that almost got to an El Nino but never made it, and then back into a negative index for the winter of 2017-2018, back to more neutral conditions this spring. Also in the red text down there, we found a coding error in our program, and we ended up reading the CM3 precipitation twice instead of switching to the CM4. So the two charts are identical on the left-hand side, indicating the precipitation. You can see on the right, the two charts look different now, so we fixed that problem. And it'll have some effect on our predictions. Hard to say how much, just because I don't have a good idea of how the CM4 precipitation is biased in relation to the CM3. All right, so we'll look at the starting conditions for the 2018 seasonal prediction. As I mentioned before, the drought code can be fairly important. Fall conditions, and I'm just going to try something here. I'm going to draw some lines on the graph here. So the area in southern British Columbia got circled in a reddish purple there. Some of those drought code values were in excess of 1,000. We see that in hot, dry summers occasionally, but I think the more normal values for the end of the summer are probably more in the range of 700 or 800. So quite a bit above normal. I think some of those areas are probably in the top 10th percentile of drought code for that time of year. We're looking at the end of October here, but it's generally pretty dry through the summer and into the fall through that region there. Some of the areas might have reached record values. We don't have a good idea of all the numbers. We use both provincial stations, and we don't have a good history of the provincial data in our system yet, and Environment Canada stations. Certainly fairly high throughout the prairies as well, and lots of high values, which are fairly typical, I guess, for late summer, early fall in the west. The map on the right here is the Canadian Wildland Fire Information System drought code map for the middle of October. I didn't choose exactly the same day, just because when we get into October, we're starting to lose a lot of the calculations in the north and the Northwest Territories and Yukon. Temperatures are getting cooler, might be snow starting to accumulate in some areas, so we tend to shut down calculations when we think that winter is set in. But still, our upper class starting at 425, is maybe a little too low to represent well some of these extreme values that we're seeing. And maybe we need a new class, starting at maybe 800 or so and above for the upper class there. So something we'll be considering in the future. Let's see, just 1 second. Close up the drawing tool. Advance the slide. All right, spring startup conditions. The map on the left-hand side is past 6 months precipitation as of May 7th, 2018. So that's percent of average. This is an Agriculture and Agri-Food Canada seasonal map. So mainly represents agricultural regions. We've got a few scattered stations throughout the forest. They don't use any of the provincial fire weather stations in this assessment. First of all, what we noticed this spring was extremely dry conditions in southern Manitoba, southeastern Saskatchewan, and stretching northeast along the Manitoba-Ontario border towards James Bay. So it's kind of the first hint that without a lot of snow cover in the winter and early melt, they might have some fire problems in those regions. The area that had the worst fire problems in British Columbia last year isn't well represented on this map, so in the left-hand red oval there. It is starting out reasonably dry this year. We'll see that shortly. But other parts of the province, if you go a little farther to the northeast, well, around Prince George, Fort St. John, they had a huge amount of snow over the late winter and early spring. So you can see an indication in the southernmost part of the province in the mountains too. With heavy snowfall in some of the mountain areas as well. Some other parts of the country had pretty good snowfall over the winter. You can see on the map on the bottom right there, we've got the snow depth anomaly in centimeters, and the map that you see right now is for April 10th. A lot of blue showing up from northern Saskatchewan right through northern Manitoba, Ontario, into Quebec and Labrador. By the time we get to May 6th, however, most of that snow has disappeared, and the fairly rapid trend from winter to summer-like conditions, we had a pretty fast melt, contributed to flooding in some areas, but kind of also opened up a lot more of the region to possible fire problems. And Canadian Drought Monitor map just at the top right there is another agricultural nega-food Canada product. These are drought code analyses to help supply information in the forested regions during the summer, but not so much over the winter and spring yet. But you can see that area from southeast Saskatchewan up to Hudson Bay that's yellow, orange, and brown, indicating various levels of drought. The other area that's kind of interesting, I think, is northwestern BC and southern Yukon, with indication of fairly dry conditions up there. Now, if we take a look at our drought code maps from about a year apart, the one on the left is May 13th, 2017. And British Columbia started out with reasonably low indexes, and same with Alberta. Look at the map on the right from May 13th, 2018, you can see a lot more green, indicating more dryness than the blue area. A lot more orange and red throughout the prairies, so an indication of drier soils through quite a bit of the region. So another bit of a warning bell there. We're starting off the spring with higher drought code values, so more deep dryness in the forest. Probably the critical period for precipitation is about mid-May to maybe early to mid-July, and a lot of Western Canada. We get good spring rainfall there, then things will be okay. We tend to get a spring bump in fire activity, and then trees green up and we get more moisture through that period. Things settle down a bit. Then rainfall tends to taper off through the latter part of July and August and September. So with forest drying through that period, we tend to get the biggest increase in burned area, plus more lightning, I guess, to increase the number of starts. So, it's really critical. If we get rain over the next couple of months, it might be okay. If we go through another dry period, then, we could have some fairly widespread fire activity again. All right. Now into the 2018 seasonal prediction. I'll start out just by looking at the CMC climate model forecast. Now, I've alluded to the ENSO and sea surface temperature anomalies a lot. So when they calculate the ENSO index, as far as the sea surface temperature anomaly, they're looking at that overlap between the 3 and 4 regions. So it's inside the red box with the 3.4 in the middle of it. So it's that area of the Pacific Ocean where the sea surface temperatures are averaged. The full ENSO regions are shown in the box there, the 1 and 2 regions off the west coast of South America, 3 a little farther west, and then the 4 extending further west towards New Guinea and just north of Australia. The model plume this is from the middle of April. Unfortunately, this presentation is about, I think, 3 or 4 days before the next plume is available. So in a few days, we can probably see the next prediction. But from mid-April, again, we're kind of looking at a return to El Nino conditions as we get into late fall and winter. And once again, there's the limits there, the plus and minus 0.5 degree anomaly. So by the time we're getting into probably September, October, November, maybe October, November, December, centered on November, we're seeing the red and green lines start to pass that positive 0.5 anomaly. So those are the averages of the dynamical and statistical models. The Canadian model, the CAN-CFS, appears with the purple line with square boxes on it. So just highlighted those with the purple arrows here. So you're going to see that it's maybe sitting in close to the middle of the pack, maybe a little higher, I guess, for the dynamical models, though. Just another way of looking at this. The gray areas indicate high probability of neutral conditions, and it's probably quite neutral right now, so that's why we've probably got a 90% chance of neutral conditions occurring at the present time through the spring. By the time we get into the middle of the time period, though, August, September, October, we're starting to see the red bar become a little bit higher than the other two, so we're seeing a greater chance of an El Nino starting to happen, and of course that continues to increase over the winter. Right, now just kind of a recap of the seasonal forecast methodology. These are fall conditions adjusted for the spring. We apply an overwinter adjustment to the drought code. So we start with the certain value in the fall just before the station shuts down for the winter. We adjust that value based on the amount of winter precipitation and kind of a rough idea of the soil type, which determines how well water may soak into the forest floor. So we come up with our spring estimate of the drought code. We calculate the daily average weather for a 30-year period. You only have to do that once at the beginning of the season. Once it's there, we can use it for the following seasonal forecast for that year. Then we take the model output, calculate our FWI and severity rating for a number of stations across the country, determine how much above or below normal that is, and then we come up with our anomaly maps. So the CAN-CFS forecast for May, June, and July. On the left, showing probability of temperature above normal, seems to be highest in the Atlantic Canada, southern Atlantic Canada regions, with the patch of red over Nova Scotia and lots of orange in the surrounding countryside. But still showing, at least a 40% or higher chance of above normal temperatures across a pretty broad part of the country. And the parts that are maybe normal or below normal in the Arctic and maybe along the northern Pacific coast. On the right, precipitation probabilities. It's probably a little bit harder to predict. A lot of the west showing higher probability of below normal precipitation through the spring here. We're going to jump a little bit into the July, August, September period. Temperature prediction on the left, showing just about all the country expecting a good possibility of higher than normal temperatures. And once again, more pronounced over Atlantic Canada and over British Columbia. And once you get out this far with the precipitation, it's probably really tough to pin down a trend, and the map on the right doesn't really show any definite precipitation trends. Now, we might, we're starting to use other models output as well. We don't input the actual output numbers as we do with the CAN-CFS models, but we'll do a visual assessment for now, and some of this might show up on the North American seasonal assessment. So here's just an idea of the output that we're looking at. There is a blue shape there that we've outlined. Right now, that's just the same shape on all of these, just for I guess a representation of the method. These are just temperature plots. We also look at precipitation. So on this map, or a series of maps, you might see the area around James Bay that shows up in red or orange on some, but maybe blue or white on the others. And that area is based on precipitation as well, but we're not showing it here. So maybe a little worrisome is the fact that I don't think I've ever seen this much orange and red on the temperature plots before. All of these models pretty much are showing a large portion of North America expecting above normal temperatures throughout the summer period. Just a couple that are showing, patchy areas of blue or white, I guess more so towards the northern part of the country. Right, so into our own model predictions here. Just, I guess, a few items that we're doing differently or new items. We got our process more fully automated, so we've got less chance of failed runs, and even if things did crash in the past, then Kerry would run around and get everybody alerted that their part has failed. But now it's pretty much all automated, so less chance of having that happen. So probably a better chance of having things posted, I guess, at a similar date each month. As I mentioned before, the classification of anomalies is a little bit different, showing below average and above average periods now, and more distinct classes. Of course, what I just did on the previous slide, the visual assessment of other models' predictions, and we tend to produce a map like you see here for briefing notes for the Federal Minister of Natural Resources, and those shapes will also appear in the North American assessment. And we haven't got those in the Canadian Wildland Fire Information System, and I forgot an F in the acronym there. It should say CWFIS. Part of the problem there is we have to get any descriptive text translated, so it takes a bit longer to get those things posted. All right, so our predictions, the May run, this is the May 1st run here. For May, we changed the area a little bit from our April prediction in the prairies, but we're still seeing that elevated area through southern Manitoba and up the Manitoba-Ontario border. There's a little dot over in west central Saskatchewan. I think in our previous prediction, we had a bit more of that prairie area highlighted, which maybe should have been. Still true, but we changed our classification scheme a little bit, and that's what we came out with. In the center, we've got the area broadened out a little bit for the briefing note and for the North American seasonal assessment on the right. June looks like the models are expecting fairly warm and dry conditions through the rest of the spring and into early summer, so we tend to get that prairie area broadening out quite a bit, as you can see on the left. It's fairly jagged just because the number of stations is limited in some areas, and maybe that's something that we can improve, is the number of stations with a good historical record of weather that we can use for a baseline. Briefing notes map in the middle and the North American seasonal assessment on the right. So we've extended that a little bit around James Bay, just looking at some of the other models' output. July, the area continues to broaden out. And into August, fairly close to July a bit, but maybe we're starting to see a bit of a reduction through the northern areas, but certainly covering a large area of Western Canada still. Once again, we've extended that a little bit further to the east for our briefing note. We don't have a North American seasonal forecast assessment map here, just because they only post 3-month periods at a time. Just to run through a few sample plots here. Some of these might be temperatures, some might be precipitation, some might be the cumulative severity rating, which you see here for Cranbrook, BC. Precipitation for both the CM3 and CM4 models appears to fall below that black line, which is the 30-year mean. So we're looking at dry conditions through at least southeastern BC. You can see a corresponding increase in severity rating on the plots on the right, especially with the CM4. The little key map on the right-hand side gives an idea of where that station is located. Fort St. John, northeastern BC. Looks like probably a trend towards warmer temperatures by summer. The precipitation on the right, maybe a hint that it might be a bit dry, but nothing too ominous, I guess, there. Fort Simpson in southwestern Northwest Territories. Kind of on the edge of the higher risk area for the summer, so it could go either way. They might get enough rain to keep things I guess under control there, or it might be a bit on the warmer and drier side, and things might light up again. Certainly with the seasonal severity rating, especially on the CM4 plot on the bottom there, it suggests the possible indication of higher fire potential. And the Pile, Manitoba, which is kind of on the probably northwestern edge of the active area at the present time, Temperature plots on the left suggesting warmer than normal conditions probable through the rest of the spring and summer. And the precipitation on the right, a good indication that things will be drier than normal there. So it's kind of right in the middle, I guess, of the area that's indicated as high for them, the prairies. So we look out Ontario a little further to the east. Definite indication of warmer than normal temperatures. Severity rating on the right there showing most of those model ensemble elements are above that normal line. So good indication of a higher severity possible through northwestern Ontario. And if we go east to Wabash Lake, Newfoundland, it's nothing really dramatic here, but the reason I put that in is it's just on the east side of the extended area around James Bay, and it's kind of looking like precipitation may be enough for, temperatures might be cool enough not to ramp up conditions too much that far east. So getting close to the end here, a few notes. Forecast temperatures are higher in many places in the May forecast compared to April. So climate models have all come out with indications of much warmer than normal temperatures, and it's quite a bit more dramatic than the April forecast. And you might have noticed that one of the model ensemble elements is predicting really high temperature departures during part of the year. One ensemble element probably won't affect the forecast too much, but it's something that we should still investigate and try to identify what's different about that model element and why it's only in the spring. And something else that kind of kept in the back of my mind over the past few years is we had a change in the Pacific decadal oscillation phase about 4 or 5 years ago. So that black arrow is kind of pointing to that change, probably 2014, 2015, maybe a bit before. So gone from a blue anomaly, a negative anomaly, to a positive one again. And look at the precipitation in Calgary over the preceding couple of decades. It had been increasing in the spring quite a bit, but with that change in phase of the PDO, precipitation seems to have been knocked back quite a bit in spring at least, and maybe through the summer. So maybe something we'll just keep in mind, I guess, for future predictions in Western Canada anyways. And just looking at Calgary, haven't looked at the surrounding area, but I think that maybe southern Alberta is similarly affected, and maybe other parts of the southern prairies, possibly even BC. So in the future, we're still working on refining our anomaly map classes, so we'll probably sometime over the season see one more new addition to the Canadian Wildland Fire Information System maps. We want to put get the seasonal software into the CWFIS architecture. And when we do that, we're going to consolidate all the pieces of code into one location, one architecture. We'll have it better documented, and probably understand it better ourselves and explain it better to other people. Snowmelt estimate for the spring startup, we're just estimating snowmelt based on 30 years of past observations, and we're just coming out with a rate and applying that to the current snowpack. So in no way are we using the forecast temperature and precipitation yet to estimate snowmelt. So it's something that maybe we can do. Maybe Environment Canada has a way of providing that information in their model output. It's something that we can investigate. As I mentioned on one of the previous slides, we had a better understanding of all the ensemble members and parent biases and some of the kind of oddball predictions that some of them are making. At some point, and this is probably a few years in the future, it'd be good to actually get the input data from other climate models, and then we can assess those the same way that we're doing the CANCIFFS model output. We've got the two presentation methods, one for the CWFIS and one for the North American assessment. And at some point, we should bring those together so that they're both saying the same thing. Hopefully, in the future, we can get more input from provinces, maybe incorporate some of their own methodologies, find a way to adjust the areas based on those. And of course, as we develop these different steps, we should be, I guess, developing a better way to assess the model performance as well. All right, just things to watch for. As I mentioned before, we do a new forecast in the first week of each month. So, those should be posted on the CWFIS, or North American Assessment, usually by about the 7th or 8th, I think, of the month. And watch for the new anomaly classification scheme on the Canadian Wildland Fire Information System. And I guess just to keep up to speed on conditions, you can visit our site and look at daily fire weather maps. You can look at the interactive map, look at hotspots. Most of the provinces and territories have a website that you can visit as well. It gives current conditions, things like evacuation, alerts, fire bans, things like that. So, just urge everybody to keep up to speed on changing conditions with those, I guess, daily products as well. Because we do in the seasonal forecast, we do it by month, but really the conditions may start to change in the first week or the third week, and they rarely ever line up with the end of or start of any particular month. So with that, I'll end the presentation and just see if there's any questions out there.
Okay, great. Thanks very much, Richard. Very great presentation. Lots of good information on the methods used to develop the forecast. And I should mention, I neglected to mention at the beginning of the webinar that these webinars have been given by Carrie Anderson for several years, and you'd mentioned Carrie's name in the presentation. So Carrie Anderson, I understand, retired recently, and so that's a bit of context to Carrie Anderson's mentions of Carrie Anderson's name. And just to remind everybody that you can use the Q&A function to ask questions whenever it's convenient for you. Richard, just a couple of questions about the use of the seasonal forecast. So in your bio, you mentioned that you're involved with the Canadian Interagency Forest Fire Center, CIFFC, and of course, one of their functions is the sharing or coordinating the sharing of fire management resources during the fire season. Are seasonal forecasts considered in the planning of allocation of resources for wildland firefighting by CIFFC or provinces, and just a little bit more information about how the seasonal forecasts are used in the industry?
Right. Okay. Well, we could go on a fairly long answer here, and some of it I probably can't answer, but I'll do the best with what I can here. Seasonal forecast, I did a similar presentation about a month ago to the Wildland Fire community at large, and CIFFC, the Canadian Interagency Forest Fire Center, hosts a series of webinars similar to this. They call them National Conversations. So I cover any topic related to fire. So we'll generally do one of those to CIFFC and the Wildland Fire community at large in April. So I did that. Now, I can't really say for sure how each province or territory may use our information for their own purposes. We'd have to get the provincial people to answer those types of questions. It may be too lengthy of a, prediction to actually go about arranging for equipment, but it's something that, that CIFFC will probably keep in the back of their mind just for the upcoming fire season. It may help with preparation in some way. We also do, have Public Safety Canada's Government Operations Centre involved in a lot of our briefings as well. So, they might kind of store up that information too for reference. I think what's maybe more useful for planning is maybe shorter term briefings, and we do a weekly fire weather outlook for CIFFC on Wednesday mornings, and in fact, that's what I was doing just before I started this one. So on Wednesday mornings, they have a duty officer conference call where all the provincial duty officers will call in and outline their equipment needs or personnel needs, or state whether they have crews or equipment available for other provinces. So, the weekly briefing is maybe useful in that context. If we get up to a national preparedness level of 3, which means that, we're getting resource exchanges between several provinces, there's probably a couple more agencies that have active fires then. We kick in another level, we get our international affairs person involved from Ottawa, we get the GOC, the Government Operations Center, involved, and we get the CIFFC director involved, and that starts preparations for obtaining international resources if necessary. So if that preparedness level is 3 or higher, it's on a scale of 5, then that unit kicks in. If we get up to a 4, then we might actually get to the need of obtaining international resources. So, there's several countries that we can call on: the US, Mexico, Australia, New Zealand. We're working on agreements with other nations as well. So there's this chain of events that can start taking place. But I think the seasonal forecast is maybe not close enough to the matter at hand, really, to really start planning for equipment and resources. I think it's maybe more of a 2 to 4 week lead that would be more useful for that.
Okay, great. Thanks very much. Another question related to, I guess, the driving factors for fire hazard over a season. So you mentioned a number of input variables, drought, temperature, and that sort of thing. In your opinion, what's the most important driver? Say if you're in a region exposed to fire, thinking southern Manitoba, it seems to be drought that is the most important determining factor for the fire risk, at least for the early part of the season. Drought as opposed to, I say, predicted temperature extremes. What do you think is the most important factor driving?
Yeah, it's kind of interesting. Humidity actually plays a bigger role than temperature itself. But of course, if you have dry conditions, you've probably got heat, and once you get fires going, if you don't have precipitation, then you don't get that help from Mother Nature to extinguish them. Wind, of course, is another big factor too. And if you get a fire going, if you get a moderate to strong wind, of course, it can drive the spread very quickly. And the wind is actually a very big driver of fires. Unfortunately, it's probably a bit harder to predict in the long term. Both precipitation and wind events are maybe just a little harder to nail down on. The wind is more of a kind of a synoptic individual weather feature related. So have to predict where low pressure areas or high pressure areas are going to be at a certain point in time to really get a good handle on the wind and the precipitation. Therefore, they're big drivers of fire, but harder to predict in the long term.
Okay, thank you. And a question from online participant George. The question is, could the CWFIS monthly fire risk forecast be taken as a good proxy for local drought risk forecast, which I understand does not exist in Canada now?
Well, we've got a group, the work that we're doing with Agriculture and Agri-Food Canada. It's the group out of Regina that's leading the drought monitoring conditions for Canada. So, one of the products that they're looking for is a drought outlook. So, that might come about in the future. They probably use maybe similar assessments with look at temperature and precipitation, forecast anomalies for the country. I don't know if the fire, maybe the fire risk can be sort of a proxy. It doesn't actually predict the number of fires or the area burned. I mean, those are really related to daily weather conditions. Like last year in BC, if we didn't have a dry lightning event on July 7th and 8th, then they probably wouldn't have had that big catastrophic fire event. So there's kind of individual conditions that maybe determine how much fire activity there actually is. But the conditions that increase the fire potential maybe could be a proxy for kind of a drought outlook as well.
Okay, thank you very much. So at the beginning of the presentation, you had a chart giving some figures on both area burned over time and number of wildland fires, and one of the observations there was area burned seems to be increasing, number of fires seems to be going down, and there's a few theories about why that might be.
Right.
Yeah, on that topic, I'm curious about how an individual, how is a fire classified as an individual fire? You know, thinking about, you know, a situation where you could have multiple fires starting in a local area. You know, how is one fire classified as an individual fire and sort of factored in and counted in those stats?
Yeah, I think, you know, these days there's probably a much greater variety of reporting methods. You know, in the past you'd have people in lookouts or aircraft maybe trying to spot fires. These days you've probably got a lot more people widely distributed. We've got modern communication devices like satellite phones, cell phones, you know, kind of internet connected devices of various sorts. So they probably have a variety of methods that people can call in and actually report a fire. You know, some of them are probably still detected by people in lookouts or people in aircraft. But each individual point would be tracked by each individual report would be tracked by the provincial wildfire people, and, you know, they determine if it was a legitimate fire or not, I think. And so I use their numbers to, you know, generate our individual fire reports. We get a hotspot, a thermal signature from a satellite, it may be a fire, and if there's a cluster of them, it most likely is a fire. We can get some false hotspots from things like rocks or, you know, sand and other types of things. We try to filter out as many of those, you know, possible false hotspots as possible. So yeah, you get those individual starts, they're cataloged. They certainly can grow and amalgamate into one larger fire, but you know, the number of fires really originates from those points that where it starts from. As far as lightning strikes go, they can triangulate the lightning data, try to get a good estimate of where a lightning strike might have started the fire. So if there's a report of smoke or fire, or maybe a hotspot close to lightning strikes, you know, there's probably a pretty good chance that one of those ignited the fire.
Right. Okay. I see. And on the topic, you had a map earlier on in the presentation showing a fire occurrence, or individual fire occurrence, and you had mentioned that, I guess, briefly at that time, that it's possible that some of those recorded fires were agricultural fires, or possibly even plowed land that were giving off, you know, heat signal.
All right.
Yeah. So and so there, the methods for sort of sorting out those varied sources of heat, are they well established?
Well, you know, we don't try to do that. I mean, that's not the data that the provinces would use. We're just interpreting a thermal signature from satellite sensors and plotting it. So, yeah, I mean, they wouldn't count as wildfires in the statistics. They'd actually have to be identified by one of the provinces as a wildfire. There's maybe ways of trying to sort out some of that. I think it's, you know, beyond the scope of necessity in our work, though.
Right.
A bit of a luxury.
Sure. Another question about so you pointed out that there had been some fires in the James Bay area in Northern Ontario. I suppose it was last year, and that it was unusual. Is there any, you know, indication of a trend in these regions, or was that just an anomaly that year?
Yeah, I mean, we do have a fire history map. I didn't show it in this presentation, but it does have a plot of all the fires that have been reported over the past, I think, from about 1970 onwards. There's a few spots in that region in Northern Ontario, but you know, they're fairly widely spaced, not very dense. If you compare that to regions farther west and south, you know, the fire history pretty much shades in the whole boreal forest area. So most of the boreal forest is burned at some point, you know, in the past 50 years or so. That area around James Bay, though, has a few scattered points, so there's been occasional fires there. The ones last year seem to be fairly numerous and fairly large for that region, but so far it's just a bit of an anomaly, you know, it maybe happens every decade or a couple of decades or something. But, you know, I'll certainly watch that area in the future and see what happens.
Right, okay.
Something
very
somewhat related to that, which I didn't show in this presentation either, is we're actually seeing a few lightning-caused fires in the tundra in Nunavut.
Wow.
That's something that we hadn't seen until maybe 5 or 6 years ago, and, you know, we've seen several cases of that. So that might be an emerging trend.
Yeah, interesting.
Yeah, not that there's a lot of people up there, so I don't think it'd, you know, affect people too much, but it's still an interesting trend, and you know, that might be due to permafrost melting and getting a deeper layer of peat that's available to burn, and it doesn't really burn, it just smolders really.
Right, right.
Yeah.
Potential positive feedback mechanism, another one.
Yeah.
Okay, well, I think we'll wrap it up there. Any last thoughts before we sign off?
All right, I guess just, you know, for the audience out there, you know, have any comments about the technical level of the presentation? You know, graphics, are they good? Is there too many? Could they be better? You know, any kind of feedback would be appreciated. Okay, right, Richard. Yeah, that's a very good point. Yeah, to the audience members, we had a pretty good turnout today. I think we had about 40 people on the line. If you do have suggestions for next year's forecast, which hopefully Richard will make time for us again, if you had suggestions about level of detail, like you said, additional topics that you might find interesting, please contact Richard Carr with the email address you see there. Thank you again, Richard. Thanks everyone for joining. And just a reminder that we have our next webinar on May 31st, and we'll have Bob Robichaud from the Canadian Hurricane Center to talk about the upcoming hurricane season. All right, well, thanks Dan, Tracy, and everybody that participated. Great, thanks again. Right, signing out.